Hi, boys. I hope you are doing good. Uh, First of all, thank you so much for showing so much love to my new videos, and really love reading those comments. So yeah, do commenting, right? I love to read them, and yeah, that is the thing. And then let's start with the video. So today I'm gonna tell you how being average at programming is basically a good thing. It's like a blessing in disguise, right? I'm not trying to hide my incapabilities or something, I'll start with a story, right? That after hearing that, you might understand what I'm trying to say. So when I started my college, right? First of all, till my 12th standard, I didn't had computers. I was an art student, right? I was a ICSE school, so arts. You don't understand arts, basically not liberal arts, like basically history, science, this kind of thing. I had math and science, and I had an optional between math and bio, so I took math. Then I had option between uh, art and computer. And I'm coming from a poor family, right? I didn't wanted to put a lot of burden on my father, like giving extra. So we had this extra fees if you take computer, like then you will get access to the labs and all, right? And so I was like, I don't want to put burden on my father, paying that extra fees for lab. And I somehow felt like this is a thing, right? I could easily learn it. For me, it's not really hard. And I was struggling a bit with maths and science, and these three subject, math, chemistry, and physics, was too much for me, right? I didn't wanted extra subject to be on my neck all the time, hanging around my neck. And art was natural to me. It was easy. There was no prerequisites to follow, right? And basically, yeah. So art was not very much was a burden to me. It was natural to me. And also, if I have tell you my stories of past, I was very dumb when I joined my first school, right? I was coming from a very Hindi school to a very Christian school, and there I was, my dabba was goal, like basically. I didn't. I was doing poorly in academics, and art basically came to rescue. In all the subjects, I was never appreciated or never be like you're doing good something. But in art, I'll do, and my teacher will really like boost me, like, oh, you're doing good. You draw such beautiful thing in draw, and that confidence somehow transferred to my other subject. And literally, when I reached my 12th standard, I was very okay and good with other subjects as well. So art was always a rescue to me, right? And so I somehow I felt like computer is something I'm gonna pick up very fast. I felt like that is in my blood, right? My families all are like basically uh, electricians, engineers, right? All of them are like half of the family, if I look back, is either they are teaching, right, or either they are some kind of electrician or something like this, right? So I felt like this is electronics is my thing, and I could excel any times programming, this kind of thing I can do, and better to focus on math and science, which is hard for me. Since 12th I didn't took computers, right? So I never had a programming, and never knew programming when I reached my college, my graduation, right? That was BCA. So I never knew programming, right? And my first semester started with programming, right? And I was very astonished saying this, how would you write something print and that will display on your screen, right? So I was very confused. How I knew like something is open, but I was very curious because this whole programming is abstract, right? This language like C++, it's an abstract language. There's a lot of thing behind the hood happens which we don't understand as a programmer. We just know that if you write something, some effect will come, cause and effect basically. So that was there at that time, right? So I was very confused, like how it is happening for me. Yeah, programming is good, but I don't like abstraction. I don't like things hidden. I'm very curious guy, right? Obsessive curious guy. So I wanted to know what actually happened, how this display, how these pixels glow, where the commands are given, how it actually like the program which I write basically goes and lights up the screen in a different way. What I have commanded in the program. So that made me very curious, right? So instead of actually learning programming or something like this, I didn't took programming seriously. I was more like wanted to understand how actually the abstraction work, right? So I started learning about microprocessors and these all things, microcontrollers, and going literally understanding digital gates and everything, how this basically how screen works, how pixel works, right? So I got into that zone, which is outside of the syllabus, right? And there was programming was required, and I was not very. I thought like maybe I quickly like run through this kind of thing, and somehow before the semester ends, I will come and learn programming, right? And I was researching very hard on something, right? I really came across a book called How They Do It Now by James Scott or John Scott or something. This is basically Scott microprocessor, right? Basically, it was a semi-programmable, hardwired 4-bit microprocessor, which it was designed in a book. And from there, I like basically I opened the black box of Pandora, like understand how basically with a NAND gate, basically you can build all the computers, right? And like how control unit work, how ALU works, how everything, like I look from bone to bone, I understand from cell to cell, from gate level basically I understood. And then I understand how compilers are, right? And do you know this interesting stories? If I ask you a question, how in which programming language C is written, right? And then the answer is it is written in C. So it's a like chicken and egg problem. How like how you can write C for the first time when the C is not invented, right? So that these were the questions which used to make me very curious at that time. So if I have to answer this question, basically it was written in assembly. Once you have compiler in C, right? You have written the compiler in assembly, right? And once the compiler is written, you have a compiler which will generate C code, which will convert C code into binary code, machine code, right? And that will work like this. Now what you can do, the version of the assembly code which you use to write the compiler, you will write the same thing code much in optimized way with a less size everything, using the compiler which you build. Basically you want to write yourself again, right? You want to update the version. So first version of compiler, C compiler, was in assembly. Second one, when the basically it's like bootstrapping yourself, right? You make something like I make a robot with a wooden and plastic and everything. Now when the robot is alive, he has the intelligence. He will go back, change his wooden arm and plastic arm with metal arms, which he has built by himself, right? Something like that. So when the C compiler was made in assembly, now the assembly, like basically you can rerun all those codes, like rewrite the code using the new compiler which you have built, which will write C code. So that way we see that C was made in C only, right? But the first version was in assembly. So like it was beautiful. And then once I understood how every bit of things work, what the library, what is compiler, what is JIT, just in time like everything, there was two kind of compiler. One is interpreter and compiler. So these things like was not black box to me. For a lot of people, a lot of programmer, it was black boxing. For me, I knew what actually going inside the CPU, like bit by bit level, and how it is displaying on the this thing, right? And the later we had actually a course on microprocessor and controller, right? And for me it was advantage because I was already studying, right? And do you know that my hope like then the first, I think first midterm, whole class failed other than the one guy was topper who could memorize anything. That guy didn't fail, and all class failed basically in that subject, and I was the second guy who passed, right? It was such a big achievement for me, because all the things and nobody understood. The teacher was bad. It was too much memorization for everybody. Nobody understood microprocessor because teacher will only tell you about trigger, this command will do something. Nobody knew deep inside what is happening, right? And I still performed, like I passed on the midterm, right? I was very happy. And in the final term I thought that I would get a lot of good marks, and but I unfortunately didn't got. I just got passing marks of 40 or something like this, and I was like surprised, like. And also I remember I didn't did good too, because the syllabus which I had in my college was Intel 8085, right? That was the processor. I think it's 16-bit, right? And it is semi-programmable. So the control unit for this 8085 is semi-programmable, right? And the research which I've been doing, it was the control unit was hardwired, right? And I didn't knew the difference. I didn't understood 805 that well. I was just bringing a lot of information what I have studied before, and I was thinking it is also have same control unit as hardwired, right? And there this mix up happened, and then probably I wrote answers in a such a way, right, which was more from the control unit from hardware side, but it was semi programmable 8085, and that bugged my intuition at that time, right? And later after the exam, I dig deep, and then I came to know, oh, fuck, 8085 control unit was semi programmable, and the way I was answering it was more like control unit of hardwired. So that fucked like my exam at that time. Also, I am pretty sure that the teacher who was teaching didn't understood that well. Like they just memorized things and just pass on. Nobody was like went into that deep what I went, right. And even I was thinking to make, like I was just wanted to make a simulator, just like a hardware descriptive language, basically on Java. Like basically I wanted to construct each gate like a program, like an AND gate as a function, NAND gate as a function, and then use this function multiple times to make a CPU or something like this, right? And there was a course called HDL, right? No, there was a course NAND to Tetris in Coursera, right? Which I came across, which was doing the same thing which I was doing, but it was not going in that detail. They also had a lot of abstractions. So I did that course, and midway I left it, right. It was a good course, but I understood how you can, like, today world dies, right? If all the people dies and we have to restart the generation or something, like, all, not all people dies, all the databases, all the books and everything dies, and somebody is to tell you, I tell you, hey, go, come on, build the computers, laptops which people were using, you will not able to build it. Nobody remembers how actually build. It is all stored in like one or two. I think in the world right now there will be only few person who could literally know scratch from scratch. They could build a computer like 32 bits, whatever, 64-bit computer, right? There's so much things, like it is so compressed of so much gates and nobody remembers. But somebody has to start from scratch. I think I would be the guy who could made, like, if apocalypse happened, all the computer goes away, there's no library, no books or something, and we have to start the computers, somebody has to build the computers again. You programmers will never able to do that, I can tell. And I think there my all the hard work and research will come in action, and I think I will be the guy who could make in that scenario. So that was my thinking back then, right? It sounds weird, but it is what it is. So so that time I went through that, and because of this thing I was not focusing on my programming that much, right? I understood what is happening, everything, right? I didn't practice programming as such, but the other people are doing, right? But I knew how to say. And then on later on I catch up on programming. Then as soon as I learned C, then the whole curriculum switched to C++. As soon as I was stepping into C++, the college was ahead in Java. Then I went to Java. As soon as I in Java, they kept in JavaScript. So I never be like very much regular or any level, understanding the basic. Everything was changing a little bit. So because of that, I didn't had this syntactical understanding. I had this understanding, like structural understanding. Everything is same, loops are same, conditions are same, but I could not remember the syntax very much properly, right? So I have to Google a lot while writing a code, right? For me, it's very hard without Googling or getting the syntax from Google and then write my code. I knew the way of writing, I knew where to put things, but I have to Google a lot like this. And because of that, I feel like I'm average programming, right? Average programmer in terms of writing program. But I do the job, right? I've been in the industry for a long time. I've completed so many projects, so I could tell I am a decent programmer right now. Uh, so this way I was never able to stuck into one syntax, and that was blessing in disguise. What happens is when you are too hard on a language, writing everything in language, you remember everything. Now unlearn yourself and learning something new becomes very hard, right? When you understand a programming language deep into its core and you mug up all the syntax, it's like you write everything, you know how to define class, everything, like you know the syntax. Now if you have to unlearn and try to switch into new language, it will be hard. And for me, it was a blessing. On the first place, I never remember the syntax too hard, right? So whenever the Python, so there was no Python in my college that time, nothing. So while I was learning machine learning, I started with MATLAB, right? So for me, on the first place, I knew programming, basic of programming, but never got memorize any certain language or its syntax. For me, doing programming on MATLAB was easier, right? For me, switching was easier, so I could easily do on MATLAB. Then when I was working after learning for 1 year or something, then I had to do on Python. So on my job, actually I learned Python and started doing like that. And for me again, it was easy because I didn't hard coded all the concepts of MATLAB or Java or C++. Like basically know even the JavaScript. So then I started working on Python, and then at some point I was just even started learning Swift. That was not even hard for me. So you can understand, and I understand HDL as well a little bit, right? So for me, like basically it became blessing, and also in the machine learning also, right? Although we use Python, but a lot of things are over there linearized, right? Basically, you try to use matrix manipulations to do a lot of your operation, right? Because then you can utilize the power of GPU. So you cannot write lot of loops, right? When you write programs in Python for machine learning models and everything, your goal is to make it faster, make the training faster, make the inference faster, right? So we don't use a lot of classical way of writing programs, right? So we have to take care of a lot of parallelization. So you have to linearize. You basically write convert the input in the form of matrix, then all the transformation mostly in matrix, so that you can take the advantage of GPU. So my brain was not hardwired of way for the certain kind of programming, right? I knew basics. I just knew a done thing. So for me, like I was already not in the like I was in a very moldable state for new thing, right? So I could understand that point, and I was really good at writing GPU based programming, right? Like basically using a lot of linear algebra and this kind of thing. So for me it was easier, right? Somebody who is very hard coded with the idea of normal programming, for them to think like that and write in a parallel way will be hard task. Even after that, I wanted to learn JavaScript and wanted to make my own website and try. I was making basically learning tutorials in JavaScript, right? Probably if you want that, I can share my website where you can learn about this kind of thing, where I use JavaScript to teach machine learning concepts and everything, right? So that it could be really dynamic, and they could plug in, like switch and play, experiment with the numbers and see the outcome, like how outcomes changes, so that it become very interactive, right? And then again coming from that side, then like JavaScript, it didn't matter to me, right? It was the same like programming. So for me, switching language uh, doesn't is not a big problem, right? As told you, right? Because I'm not like hard, like went hard into one language. But I now feel like I've been like Python has been like have been like, even I'm if I wish to avoid it, somehow I've done more on Python. So I think I feel like very comfortable with Python right now. But I have no issues choosing changing on some other. And even if you feel like this advantage came for me when I start like from normal machine learning or working on GPUs, writing code which will run on GPU or on a classical system. When I became a quantum computer engineer, right, now it is a whole different ball game. All the rules of programming doesn't work over here, right? It's a different way of programming, superposition, interference, entanglement. Like it's a totally thinking, like it's like a parallel world of programming, right? And bizarre terms and everything, right? And basically going back at circuit level, right? So that actually helped the HDL, the gates and NAND gates which I read. Now it is helping me also. There is a different kind of parallelism that goes over there. And if I've been very much into programming, like if we are very hard coded to the certain way of programming or certain style of programming or certain language or framework, then I would not able to learn this new skill. For me, unlearning would be hard. But I've always been flexible, always being average kind of helped. And then I easily I was able to take up. Initially, it was hard, but I was able to take up quantum computing, quantum machine learning, and the way to program quantum computers, right? And I became so good at it that I won a prize, right? 30,000 euro prize, basically for my company, And for because of that, I was able to visit 5 countries. Right, I was invited to display that algorithm, which basically that algorithm was written in quantum, and it could beat a classical system with speed and accuracy. Right, and it was this software was for satellites. Right, and satellites are moving really fast, so any speed up in the processing is very important, and it saves a lot of resources, right? Because you need really fast calculations and everything, and if you do slow, the target will pass over, and then your whatever the output comes from your algorithm will not be helpful to anybody. So yeah, being so you can say ignorance is the bliss, which I heard from Nolan in his movies Tenant. But I would say being an average programmer is a bliss, right? I'm moldable to a very new language very easily, where other people will find hard. So it's like how you see the world, right? So I hope this kind of help. If somebody is like that, if they find relatable, do comment. I love to read your comments. So probably see you in the other video. On the next video, I will be making on something like this. Maybe how to next video probably on how to write good machine learning code, and how to like end your projects very smoothly or something like this. So I hope you subscribed so that you can watch that video. So see you in the next one.